Thanks to the crowd for coming back for the last session. I was at an international conference a couple of months ago, and the session at 4 o'clock had one person left in the room. It's a terrible, massive conference room. So brilliant to see you all coming back. We're the warm-up act for Vanessa, who's going to come and tell you all about samsara after we've finished. But we're going to be talking about waste, and I think it's a really interesting conversation to have in a room full of innovators, because you could describe what we do as inventing things which make the world better, but we don't always think about the impact those things have, because when 1 billion people start using that thing, sometimes bad things happen. And I've been doing a lot in the plastic space recently. And you may not know this, but the first plastics were invented to be solutions to environmental problems. So did you know we used to make billiard balls from ivory because we needed a hard material to actually make billiard balls with, and we were killing elephants to do it, just thousands and thousands of elephants every year. So someone came up with a very sensible plan to sort of make these polymers, right? And then we make billiard balls this way, and we've solved an environmental problem. But now we make all kinds of things with all kinds of plastics, and billions and billions, 8 billion people on the planet use it, and we don't know where to put it, and now we've got 10 billion tons, or whatever the latest number is, of plastic that we've got to kind of deal with. And so the innovators of today are thinking about both solving those problems, undoing them, and also thinking about not introducing new versions of those problems as they're inventing their new companies and their new industries. So we've got a brilliant panel here today, we're going to talk about 3 different areas that each of these companies are working in. Most of the waste we think about are these plastic bags you're all opening with your chips now, and all the things we try and deal with in our recycling bins. But the waste which we can't see, the waste that happens in lithium mining and making packaging and clothing and making food, the waste that's happening in the unseen industrial parts of the world is immense, and I think is actually quite frightening when we see it. So the innovators that are solving that problem are important innovators, and we've got 3 of them here. So we're going to talk about their actual companies in a minute. But given that I've started with a plastic story, we're going to start with Kelpie, and I'm just going to ask Vanula to talk a little bit about what is the waste problem in plastic. Help us understand the scale of the problem.
Sure. So we all know how prolific plastic is, and I came to my founder story from being the daughter of a fisherman in a small village. So really looking at how we source and consume was how I began thinking about how to scale up a seaweed industry for all the benefits that seaweed bring to habitat and carbon drawdown. So really, the plastic concept was around how do we create a product that is so globally consumed and prolific that will drive better consumption patterns and drive more sustainable community-based living.
Right, so you were starting from the sea, what can I do with seaweed? More than you were saying, how do I solve this plastic problem?
Yeah, how can we localize this solution and stop wasting resources, sending things around the planet 3 times before we use them?
Talk a little bit about that. Why does it get sent around the planet 3 times?
Well, we've got a really linear model of creating products. In my journey as a fisherman's daughter, we worked in cooperatives in dispersed towns, and we used those local, that network of opportunity to process and create things ready for market. Now we have a very different industrialized version of creating products where we're very energy intensive. We'll extract and we'll export raw materials to add value elsewhere. And we really don't see, we just see this gap between the people at the coalface of climate change and the ones consuming in the wealthier nations just widening.
Yeah.
So that was really front and centre. I'm not actually a polymer scientist, I'm a social scientist.
Yeah.
I've been in community development and partnerships all my life. So it's around how do we actually use that human capital and work with what we have in our own backyards to create global solutions.
Yeah. So, I mean, how do we make plastic? If I'm drinking who's got a plastic? It's a very good crowd here, actually. They've been well briefed by Sally Ann and the crew. But if I had a Coke bottle, how's that travelled around the world, and where have all the bits come from?
It's actually been a disturbing discovery of mine to follow that value chain. And the things that happen to that, when we extract the oil and convert it into the resins, and then the different manufacturing processes it goes through before it becomes filled and labelled and then sent, and then ends up as waste, used once and then sent somewhere else to be put into a waste, burnt or put in landfill in another cheaper nation elsewhere.
That's right. Yeah.
So just for that one drink of Coke, you've created this enormous energy and carbon footprint, and not really any value for the countries that have touched it, that put it in our hands in the first place.
And we're not even, it's not even the pellet makers aren't even in the same factory as where the oil's coming from in the first place. I mean, it's just this whole chain and ships moving things around and lots of waste happening.
Yeah, often even between the labeler and the sealer and the filler, they don't know who had it before them, which is really interesting for me to tell them who had it before they did. So. And
then end of life with plastic, obviously, it's largely can't be recycled and can't be kept in Australia now either, can it?
Yeah, it's look, I think the human impact, it affects those same countries where they're doing all that labour and product creation work. They're the ones that are copying the pollution, and the plastic is infiltrating their waterways. They're ruining the marine ecosystems, ruining their soil health and ruining their human health. So it's just sort of a vicious cycle that is worsening as we consume more.
And when we think of plastic, obviously we think about plastic bags, McDonald's straws, all the famous things that we talk about a lot. But it's everywhere, isn't it? It's kind of, we're wearing it. It's in our cars. It's everywhere.
Yeah, and really difficult to, I think, say, change your behaviours, everyone. Eradicate it from your life. It's not going to happen overnight.
Once you start seeing it, you can't unsee it, can you? It's quite horrifying. All you can see is plastic everywhere and nowhere to go.
Yeah, I have 4 daughters, so I literally do see plastic shampoo bottles everywhere.
All right, so I mean, one of the things, plastic is used for is to make fibres for clothes, but there's more to clothing and textiles and preparing them, and lots of waste, right, Tom?
Absolutely. So everyone in this room is wearing clothing, hopefully. Virtually everyone's clothes are dyed using wet processes that haven't changed for decades or even centuries if we look at the basics. So there's a huge amount of water in that process. So the textile industry each year consumes about 5 trillion litres of water. That will fill Sydney Harbour about 10 times every year. But more importantly, we're putting a huge amount of chemicals into that water during the process, and inevitably that also ends up being discharged. So if we look at let's say we're all wearing about 1 kilogram of clothing. Of that kilogram of fabric, there's about 200 litres of water used in the process of dyeing and finishing. There's also about half a kilo of chemicals going into that water. Now, when that ends up in the rivers and streams that the water is inevitably discharged into, it equates to about 20% of the world's water pollution. So massive, massive issue there. And if you go to parts of the world that are dyeing and finishing fabrics, it's very, very apparent. We don't see it here, but everyone who lives in South Asia and Southeast Asia is very aware of this issue. Flow-on effects as well from these wet processes is the energy consumed. So you're heating a huge amount of water, that takes a lot of energy. You're then drying fabrics, that takes a lot of energy. Going back to that 1 kilogram of fabric, 200 litres of water, half a kilo of chemicals, you're looking at about 5 kilos of coal burned for that energy. And that is actually a very common source of energy for the processes. Because you're using so much, it needs to be cheap. So coal, gas are the key sources there. And that converts to about 3% of the world's carbon emissions, just from textile dyeing and finishing.
Yeah, I think fashion is an emissions story which is about to blow, isn't it? Like not a lot of people know about it, but there's a lot going on there. And like even simple things like my jeans here, like the blue color to dye these jeans. I mean, it's a pretty evil stuff, right? Like what does that look like?
In your dye vat, and it varies from different fabrics. So denim has a particular dyeing process, cotton has a particular dyeing process, polyester and so on. They're all very bad. But in that large volume of water, you've got dye stuffs, you've got acids, alkalis, depending on the process, you've got reducing and oxidizing agents. And then in the finishing process, you've got lots of nasty stuff as well. PFCs is one of the big ones used for water repellency, which is a massive issue. It's a very, very complex space, and you'll read things saying like something like 25% of the chemicals produced in the world are used in the dyeing industry, which is pretty crazy when you think about the variety of things that are touched.
Fantastic. So getting a feel for all this waste now, and of course we need to, energy is behind all this. We're trying to change our whole energy system on a planetary basis right now. Just need to make a few more batteries is kind of part of that problem. Just need to lithium is, it's everywhere, isn't it? So there can't be much waste in what you're doing.
Well, that's the thing. Hopefully, is this working?
Yeah, we got you.
Sorry about that. Look, lithium is in fact, it's becoming more ubiquitous as the day goes. So most of you have a lithium phone in your hands today. You've been using your laptop. You come on an electric car. Some of you, we talked about electric airplanes. All that's really good, right? That is a much more efficient way than internal combustion engines. But these unintended consequences that we don't see and we don't like to talk about really do come to the fore. So water is a real side effect of the current lithium extraction process. It takes 2 million liters of water to produce 1 ton of lithium. That's a lot. Now, we talked earlier about how do you actually conceptualize that much water. I don't know how you do it, but I can tell you, it's a fair bit. And so, we get very excited about the future of lithium and lithium-ion technology, and it's really important, but we need to look at better ways to do it. And as I was saying to Phil, and some of you may have seen this, if you've got your phone in front of you, and you can do just a quick Google, type in SQM and evaporation, and it may even autofill evaporation pond, and click on images, and you'll see the evaporation ponds that humanity is producing today in the Andes Mountains. And these are some of the driest mountains and regions in the world. We're pumping this water from who knows where into these ponds to make just the slightest bit of lithium to go into those phones. So it's the dirty secret, the inconvenient truth of those batteries. The good news is there's a path ahead, but there are the unintended consequences that do come to play.
Yeah. So should we get into the solution?
I thought you'd never ask. What a great introduction. So at Electrolith, we're developing, for 200 years, the process of making lithium hasn't really changed. And in fact, it didn't need to change. We didn't use lithium for much more than for glass, some medical applications, and so forth. And so really, this old process of pumping lithium up to the surface and letting it evaporate with this water over an 18 to 24-month period sufficed. It was fine. Today, we can't keep up with demand. And so we are pumping lithium to the surface and hoping for the best. And so about 10 years ago, the idea of direct lithium extraction, or DLE, which is in the paper quite a bit these days, that came to pass. And that's a much cleaner, uses a lot less water, a lot less chemistry to make your lithium. Electrolith is putting the final touches on that, the next generation. innovation, if you will, in direct lithium extraction by using some very interesting smarts from Monash University. And when we're up and running, which will take some time, we will have the cleanest and the best solution to the problem. We won't require water, we won't require chemistry, and we'll be able to run completely on renewable power. So a really good solution, and we're pretty excited about it.
And where are you at today? Like, what's the stage?
Well, we're at the lab stage. We have, the business was really put together about a year and a half ago, and through Monash University, our sponsors Rio Tinto and IP Group, we have taken this IP off the shelf, which is great. We have it at the lab scale now, and we're in the process of optimizing it. The intention is over the next 18 to 24 months, we'll have it at a pilot scale and being put to use. And one of the upsides to our shareholdings is Rio Tinto, which has a very large brine resource in Argentina, and so they've been good enough to give us access to their resource, so we can actually see it working real time. The biggest challenge we have is time. How quickly can we get this thing working versus how quickly do we, as humanity, want this lithium in our cars and so forth? And it's a race.
So I was going to ask you that. Like, what do you see that journey being, and what are the impediments? Are there regulation issues? Do you think the customers changing their processes is a big thing? Like, what's going to get in the way?
The biggest challenge that we face today is the demand is driving technology to come up with solutions right now. Yeah. And so what we're seeing is the lithium producers going to off-the-shelf technology today because they don't have time to wait 24 months. And so, the race for us is to get, certainly there's, interest for us because we want our technology and so forth, but we also, at the end of the day, want the best technology out there. And we need that 2 years to get that technology up and running. The problem is we may not get there. We will get there in time for the vast majority, but the mines that are being developed today are using what's off the shelf right now.
Have you got a kind of techno-economic line you've got to get over before the commercial people will accept technology like yours, or?
There is, to be sure, there's a techno-economic line, and we're in the process of defining that today. But what we find is that the customers, the Rio Tintos, the Albemarle's, they're pulling us. So we're not pushing the idea, they're pulling us. They're saying, look, we want it environmentally friendly. We want all the things that we need it to be, and we also want it to be cost efficient. And what we're seeing in the lab, at the lab level, is that the techno-economics will almost be a secondary matter because it will be that good, that efficient when it starts working.
Fantastic. Well, congratulations. What a great business.
Thanks, Phil.
Let's go into Kelpie and sort of understand more about what Kelpie, what this magical new ingredient is. When I've been talking to Fionnuala about this, I just think every time you think about making plastic from oil, it just seems mad. So tell us about Kelpie. What is it?
Our team has created a world first, so it's a novel polymer innovation where we've created a pellet, a thermoplastic seaweed pellet that can be optimized, so we can basically design in biodegradability and performance to mimic different types of plastic applications. And this pellet is a drop-in solution for traditional manufacturing. So we've been through industrial trials with Unilever, Colgate, Palmolive and others. And we've had the value of going behind the scenes and working with industrial size kit to validate this pellet in a scalable commercial setting. So that's been really exciting. It's food grade, it's 100% bio-based, and we've deliberately looked at seaweeds that are abundant, so waste streams, bioremediation seaweeds, and abundantly grown but not high value, so not competitive with food sources or cosmetics or nutraceuticals. So we've opened the door to create emerging seaweed industries in developing nations. So looking at even forward into seaweeds that are proving to be climate resilient, or there may not have been a purpose for those yet, but the local growers know that they grow really well, or they're even growing out of control. So it's about sourcing well, but also we've created a a blueprint for end-to-end cultivation, pre-processing, and our pelletization technology. So we're actually looking at dispersed manufacturing. And we can do this with existing aquaculture partners, agriculture partners, and flow into existing manufacturing value chains. So this actually means that we're disrupting this sort of insane history of shipping raw materials around the world to do one piece here and there. So we're adding value locally, which is the huge part of my why, actually uplifting those female farmers, creating more jobs in that value chain where the biomass is being sourced.
And just to be clear on this, if making the analogy back to fossil fuel produced plastics, you'd be like having the oil rig and the processing of the fuel, you have processing of the oil and the pellet maker all in the same place, right?
Yeah, and like it's similar to my upbringing where we're in tiny little towns and we're spread apart, you know, in Western Australia. This is the same in Southeast Asia, Sri Lanka, Africa. It's very much a hub and spoke model, so you need a bit of pre-processing, which is just sun drying and milling. These are things that are already happening in their agricultural systems. And then have that bigger capability, which is quite still, you can use local skills to create these pellets and create an industry that didn't exist before. And what we're finding is in these regions, they're desperate. Their fishing industry is now over. The fish stocks have declined to a point where there's no more fish. So this is where women are taking up a breadwinning role, and we've got a real moment to bring them with us on the uplift and distribute. You know, we've got this consumerism Western society, but we can actually distribute some of the benefit of that to these nations and create a product that's going to add value to actually heal soils when it biodegrades rather than do harm to the planet.
Did you bring your comb?
Oh, sorry, I did. I've got my sunnies. So very Aussie. This seaweed was actually collected by my Dominican Republic partners. They've got 40 million tonnes of invasive seaweed influxing that region. This year, it happens every year, but now it's hitting Florida, so it's big news. And there's no use for it. It's actually piling up. It's causing all kinds of issues, crushing turtles, all sorts of things. So we've been on a journey with those partners. They're giving local fishermen jobs who couldn't get out through the seaweed to fish. These are sunny frames that we made with their seaweed pellets. This is a surfboard wax comb. Also works as a hair comb if you want to do that.
Grab it.
Yeah. I've also got some taco holders, but we basically look at a use case with our brand partners, and we optimize for that, what the purpose of that product is, if it's a shampoo bottle or if it's a biomedical tool that you need to use in a surgery. And we'll look at the existing TDS of what they're using in a plastic sense, and then we'll basically meet that performance and that use case with our amazing team.
Just such a difference to fossil fuel produced plastic, and I sort of remember I challenged you with, well, what waste is your new system creating? No, and there's nothing. It's just kind of literally zero waste production, which I think is very exciting.
One of the interesting things that we noticed yesterday, so you presented a straw that was made out of the seaweed, and one of the challenges I think you're going to find in time is that the straw looks so much like plastic that you'd say, well, this is plastic, and if you didn't have it, written, hey, this is seaweed and it's biodegradable, people would think that actually, look, that guy's got a plastic straw. It's quite remarkable.
It's fantastic. We should get to Tom at Zefco. Tell us about Zefco's solution.
So we've established the dyeing and finishing issue in the textile industry. We're creating machines and processes that eliminate the use of water to colour fabrics and finish fabrics, but also reduce the energy and chemical footprint. So we're using a plasma coating process, which is inspired from some of the processes used in the high-tech industry to make layers in semiconductors, touch panel displays, and things like that. But we're getting it to work at very high volume and low cost. We're then using that process to produce very durable, flexible coatings on fabrics, and we can use that to apply both color and also functional properties. When I say functional properties, I mean things like water repellent finishes that are on all of your outdoor jackets, moisture wicking properties on all of your sportswear, and so on. So we don't use any water in our process, which means we eliminate the effluent discharge issue. We also use around 90% less energy, and that starts to unlock the use of renewable energy sources in textile processing, and it's just not really feasible due to cost with the current processes. We also reduce the chemical footprint by about 85%, but importantly, the chemical inputs that we can use are quite different to what the conventional industry uses. We eliminate all of the nasty auxiliary chemistry that I mentioned before. We can use, for color, we can use pigments that are derived from sustainable options, and there's lots of new and exciting businesses in that space. And we can use bio-derived precursors to actually produce our coatings and fix them in place.
So let's sort of riff just in the last few minutes with this idea of sort of systems over silos, and we'll start with you, Tom, just sort of thinking about Zefco. Like, what I think is really exciting right now is we're all building these new industries all at the same time. And we've got a very public conversation about the state of the world, the new technologies we've got to create to sort of get there. We've got targets, you know, from the biggest companies in the world and governments that are sort of driving this change. And we're having events like this saying, this is what I'm doing, what are you doing, right? And so there's the systems over silos things is really happening in a way we haven't really seen in history before. So let's just riff with that a little bit around waste. How do you see fashion changing in textiles?
Yeah, so the textile industry is an interesting one, and there's lots of factors that influence the way things are done. One of them is cost and our consumerism. But when we look at dyeing, it's an interesting one because you have this dependence on water. So you need to have your dyeing mill next to an abundant source of water. You also need to be in a place that lets you discharge that water when you're done with it. So you tend to get all these centers of textile manufacturing around areas where there's rivers, and typically in countries that perhaps don't have the strictest regulations in terms of water pollution. If you have a way of dyeing and finishing fabrics that doesn't need water, doesn't need to discharge water, and uses less energy, you can all of a sudden put dyeing and finishing in other locations in the world. So you can start to break away from these conventional centers of textiles. You can also start to rethink the way that the supply chain actually works. So typically, you know, you produce your fibers, you then weave your fabrics, you then dye and finish the fabrics, and then they go to garment vendors that stitch the clothes together. And there's lead times and freight and kind of queues involved in all of these processes. It can take like 3 months to make fabric to then spend another 2 months stitching your garments together. If you've got a machine that is simple to use, breaks away from all these dependencies, you can put that at the end of your apparel production line. You can then all of a sudden start to make fabrics on demand, or dye and finish fabrics on demand. That cuts out lead time, 2 months in a lot of cases. It also allows you to make it just in time and reduce the waste. So you can basically produce stuff to order based on customer demand. Other interesting numbers related to waste in the textile industry is that around 30% of clothing that's produced isn't actually sold. And that's because we overproduce so much, both at the fabric level but also at the garment level, just because they have to predict what they're going to sell 6 to 12 months in advance, and no one's ever going to get that right. So if you can unlock some versatility, reduce the lead times, then you can make a really big crack at reducing that 30%.
Where does that go? Where does the 30% go, do you know?
Well, I think we all know.
Good Samaritans.
To some extent, but a lot of it is wasted.
Just landfill. Yeah. Terrible. All right, so similar. So that's interesting. You could actually imagine an Australian fashion industry there, right? Because we can actually, as we're sort of starting to build new sovereign capability, these are things that are suddenly possible because we don't need these horrible ponds out in Bathurst or something. We can do it your way.
It unlocks, like there's a few different ways that it can help different regions. So in countries like Australia, it can actually enable onshoring. We can dye and finish fabrics here, and it's very, very hard to do that at the moment. So particularly if you're doing versatile, small, flexible productions, then that starts to allow that to work here because you're adding value through being able to offer different things to your customers. But it also allows in other regions, textile manufacturing, to go to regions that manufacturing have the ability to kind of revitalize regions economically.
Now, similar to that idea, Fanuli, I think you're making a similar world, aren't you, where things could be a lot more distributed, don't have to be these massive centralized processing places.
Yeah, it's like I've been playing dot to dot since I started. I think just connecting everything we already have is right there in front of us, which is incredible, but it is in different industries. So it's been a fun game of dot to dot. One of the first things I did was actually validate Australian seaweeds, so the most abundant ones that we find locally around Australia and the ones that we use to bioremediate our aquaculture. Knowing that we're miles away from a regenerative farming industry due to legislation and all these other blockages in the country, but I'm stubborn and I'm going to keep pushing that industry forward single-handedly. No, with everyone else who's been really trailblazing that industry. So I think, for the future of Australia, I'm very hopeful. There's First Nations communities that have been using seaweeds for 60,000 years, been creating really high-value medicines and food sources, and I hope to package their products in the future, and that's the dream. At the moment, I'm getting a lot of traction internationally, and what we've learned is we have aquaculture, we have agriculture, we have manufacturing, we have the logistics, and it's literally about the epiphany is that they exist in the countries that are growing the most seaweed. So it's kind of magical the way that that's aligning.
Are we, with you guys and Ulu and the methane abatement companies that are out there with the Asparagopsis, are we going to become a seaweed superpower?
Oh, we should. We're an island nation. We should be. We've got all this ocean around us. And
it's definitely a system as well, that we need to build, isn't it?
Yes.
Around this,
around
this
100%.
stuff. And Charles, can I just sort of move to you? Like, does the lithium extraction still need processing still need to happen in South America and things, or is it going to move around?
No, most of the extraction happens where the lithium is, and we do the refining primarily in China. But to your exact question, the new technologies that have been developed and we're developing will allow the lithium to be extracted and refined on site. And what that does is it unlocks the lithium reserves that we know about, and the lithium reserves that we know about today are uneconomic. And as it turns out, lithium is one of the most abundant elements in the world. It's everywhere. Every time you turn around these days, someone says, "Oh, I found lithium here, there, and everywhere." And we envisage a day where not just in WA, but other deposits in Central Australia, in the US, in the Permian Basin, there's a whole raft of these resources that today aren't economic, tomorrow could be economic as this new technology plays forward. And so those ecosystems can in their own right become economically viable, but at the same time it gets more of this product out into the market cleanly and safely, and really pushes down the price of lithium so that it can get out to the market.
Amazing. The thing I've genuinely learned today is that actually if you can think about waste differently and solve for waste, so you don't need to be in some centralized place that's going to deal with this phenomenal amount of terrible waste. Suddenly all these other industrial opportunities become possible, don't they? You can build things in other places. That's right. Yeah, fantastic. Well, we've run out of time. We could talk all afternoon, but thank you so much for everything.
Thanks,
Thank you.
Thanks, Phil.
Thank you.
Nicely done.